Alright, so this question says the net of a certain rectangular pyramid is composed of a 6-inch by 12-inch rectangle surrounded by, as you can see, two pairs of congruent isosceles triangles. So each triangle over here has two sides of length 7 inches, and so this question is asking, well, what's the volume of this pyramid? So the first thing for this question to know is like, what's the formula for the volume of a pyramid, right? Well, the volume of a pyramid is just base times height over 3. Now in this case, we can figure out the base pretty easily. The base is just going to be this rectangle that the pyramid sort of stands on, you know? So it's going to stand on this rectangle that's 12 by 6. And so this right here will be its base. And then it'll have these triangles that fold upwards. These are isosceles triangles, and they will form the top of that pyramid. But the base itself is just this. It's just that. So what is the base? Well, the base is 6 times 12, which is going to be 72. So that's why our base is equal to 72, because it's just equal to 6 times 12. And so we already have this divided by 3, which means we just have to find the height. So how do we do that? How do we find the height? Alright, so I redrew this pyramid to make it a little bit bigger and easier to draw on and visualize and write on. I realize it's not the most symmetrical, but we're going to make do with what we have. So we're trying to figure out the height, and so that's going to be this distance right here from this vertex all the way down perpendicular to this base. That's going to be the height. Now if you notice, the height forms a right angle with this base everywhere. So if we were to draw a line like this, well, this right here, that would make a right triangle with the sides of this line right here, this diagonal that goes across the base, our height, h, and the hypotenuse, which is the lateral edge of this pyramid. And you might be wondering, well, we don't have the lateral edge of this pyramid or the height, so how are we going to figure this out? Well, we actually do have the lateral edge, and that's the 7-inch figure that they gave us, because when we fold these triangles inward as our pyramid, these are going to go up here, and we get that our lateral edge is 7. So once we figure out what this leg is, we can use Pythagorean theorem to find our height. So how do we figure out what that leg is? Well, if we think about it, this leg right here in our rectangle, it's the length that goes from one corner, one vertex, to the middle, all right? So how do we find the length of that? Well, it's half of the diagonal, but the reason I know that is because, well, this horizontal length right here, it's just half of this entire length. So if this entire length is 12, that means that this length from there, that has got to be equal to 6. Same thing with the other side. We know that this entire length is equal to 6. So half of it, this length right here, that's got to be 3. So that means the hypotenuse, well, we could scale this down, but the hypotenuse is just the square root of 6 squared plus 3 squared, which is the square root of 45. So that means this length is going to be square root of 45. And knowing that, we can easily use Pythagorean theorem to find the height, this leg. So square root of 45, 7. We have a squared plus b squared equals c squared, right? But that means one leg. So like a, any leg, that's just going to be equal to c squared minus b squared. So to find this one leg h, we're going to say h is equal to the square root of 7 squared minus the square root of 45 squared. Now that's equal to 49 minus 45 inside of the square root, which is equal to 4. So h is equal to the square root of 4, which is 2. But we're not done yet. We have that h is equal to 2, but don't forget, we got to plug it back into our equation for volume. So we get that the volume of this pyramid is 72 times 2 over 3. Now 72 over 3 is 24, times 2 is 48. So the answer to this question is going to be 48. The volume of this pyramid is 48 cubic inches.